There you are now, welcome back to the garage. So on today's episode, we're getting back to this 4-speed straight cut gear kit that we're building into this box. Well, we're rebuilding into this box. I suppose I'll just start this video with an apology for the lack of a video last Wednesday and Sunday. As I'm sure you're keenly aware, we were in deep preparation for a race which happened this weekend just gone. Some very interesting comments came in over the last few days on the video I made about modifying the pistons in the race engine that we were using in the 1380. I suppose I just want to address one or two things about the comments that came in. First of all, I really do appreciate every comment that comes in, and I appreciate reading through them and listening to what you guys say. I'm sorry I haven't yet got a chance to reply to them, but that is coming and I will get to doing that. I have read them all and I have found them all incredibly interesting. Some were very helpful. Some people had some negative stuff to say about what we were doing, and some people were very positive and were very encouraging of the work we're doing. In all cases, I don't discourage people speaking their mind, so I have no problem at all with some of the negative stuff. There was one or two comments which I deleted, and it's the first time I've had to do it on the channel, but I absolutely will not on this channel abide by anybody who is going to be taking part in any form of bullying or giving out, and that is most definitely what one or two of those comments were. Look, as they say, you know you're starting to make it somewhere on YouTube when you're getting nasty comments. But anyway, we're going to keep this a positive place where we all can hang out and enjoy, and I want to reinforce that idea. I'm making this channel, guys, for you guys to be able to hang out here with me in the shop, and that's what I enjoy. I enjoy reading comments like I would have other people standing here in the shop chatting with me. It's an opportunity for us to hang out, and that's what the channel is going to be about, and that's what it's going to continue to be about. So thank you very much for everybody who does come and does hang out. To address some of the negative comments, which I'm not giving out about, by the way, I am totally happy with those. I completely 100% concur with anybody who says that it was pretty much a bodge to machine the top of the pistons as opposed to straightening up the little ends in the conrod. I do have to, however, put a caveat in that. One, the facilities which I have here would not allow me to machine little ends of conrods in line with the big ends of conrods. I just am not well enough set up here. I have small tools, small equipment, and I do like to take on and challenge jobs here in my home machine shop, but there are certain things that I know I absolutely can't do. So that is something I couldn't do. I did have the tools and facility here to machine the pistons, and that's why we went for that. The ultimate solution is to change those rods, and that is exactly what we are going to do with that engine. In fact, we just found out recently that engine spec is going to completely change. So that'll be an interesting engine build that's going to be coming up shortly on the channel. As far as how did the engine go, the engine went to Roland Road last week and it performed incredibly well. It produced well over 130 horsepower, which I was very happy with. Unfortunately, the day itself didn't go brilliant. We had racing problems and we had to retire from the race early enough on due to some problems that were not rectifiable at the track. That's a video for another day and we'll get into that. It unfortunately means that we also had to cut short our video that we were shooting for you on Sunday, where we were live at the racetrack, and we were going, on Saturday, and we were going to then edit that film in a hurry on Saturday evening and have it up for you guys on Sunday afternoon, but unfortunately that didn't happen. We did catch some footage from the track, a little bit from starting out during the day, a little bit from going up and getting the car scrutineering done and qualifying. So if people would like a short edit of that, let me know in the comment section below, and I'll ask Billy, can he try and rustle something together for you guys? He's smiling at me here from behind the camera as much as I say, you fecker. But anyway, such is. So if you would like to see some of the footage that we did shoot last Saturday, then I'll be more than happy to put some little bit of an edit together and I say I'm going to put it together. Billy's going to put it together. I'm not going to do that. I'll be too busy down here in the shop. But yeah, I'll ask Billy to put some stuff together for you guys and to get it up there. As I said, the car was running really very well, but we ran into trouble. So hey ho, that's motor racing. We'll be out bigger, better and stronger the next time, and that's what we're going to do. Anyway, I've taken up absolutely enough of your time. I'm going to crack into getting going with the gearbox. So the next job we have to do is to fit the lay shaft into the gearbox. There is two sections to the lay shaft in a mini gearbox. There is the lay shaft inner and the lay shaft outer. The lay shaft outer is the shaft with all the gears on it. It has, on a standard gearbox, it would have one needle roller bearing in that side and it would have another needle roller bearing in that side. Because this is a race item, in that it's a straight cut gear kit, it actually can take two needle roller bearings in this side. So it has two on that side and two on that side. We have upgraded from what was in there. It had this lay shaft inner on the gearbox when we got it. This item is not a race item. This is a standard road item. And what you can see is some clouding starting to form here on the lay shaft inner. And the next thing that's going to happen there, you can see it here again, is that the hard bearing surface is beginning to break up. And in very short order, what would happen is that the surface of this inner shaft would start to pick up on the rollers of the bearing, and then we would get total bearing failure and the gearbox would let go. So we've ditched that and we've brought in this really lovely high quality item, which is a competition lay shaft. This is the EN24B lay shaft. I get this through Mini Spares. They're a really, really nice piece of kit, very well made, and you know, they are made to good close tolerances. So they're a good item. So that basically inside the gearbox sits like that, and it has a thrust washer on either end. So it has a thrust washer this end and it'll have a thrust washer that end. In order to get this installed into the gearbox, you've to sort of hang these thrust washers up on the box. You've got to drop the shaft in and you've got to push the lay shaft inner through the center. So it's a little bit of a faff, but you know, if you've done a few of them, you'll get used to it. There is a clearance that needs to be checked, and that is that there is some end float to this. End float wise, typically I shoot for between 2 and 4 thousandths. On a race box, I'd probably go for 4,000 because this shaft is going to get very hot. On a road, I'd probably shoot closer to the 2 or 2.5 thousandths because it's unlikely for it to get as hot. Obviously, in a motor like this with straight cut gears and race speeds, very high RPM, high engine temperatures, everything just gets a little bit hotter, and we don't want that lay shaft to run out of clearance. The result of it running out of clearance really would be that it would start to seize up in the box. It's unlikely that it would fail a bearing, but it would put huge wear on the lay shaft itself and on the bearing surfaces of the lay shaft. It would also drag a lot and reduce horsepower and reduce contact on the road. So in order to fit this in, I'm going to try and give you the best view I possibly can. There is another thing that we have to think about just before we actually fit this shaft in. The thing we have to think about is the central oil pickup. So the central oil pickup that we're using, again, Mini Spares item, needs to sit in this position here. And in order for it to sit in that position, it has to go in with the lay shaft. It's not possible to put it in after the fact. So the way I do this, and this is not my first rodeo, is I hang that thrust washer there. Now, I've never actually done it at this angle, but I do want to try and show you what I'm doing, so that's why we're at this angle. So I hang that thrust washer there. I then make sure that my bearings are in my lay shaft. For those who are wondering, I've already oiled these bearings. I've put plenty of oil on them. They're ready to rock and roll. And I do just use gear oil in this situation. What I then do is sit that lay shaft in there, bring in the central oil pickup, and basically you want to walk the two of them into place in one go. Okay, and this is where that bit of a fap comes in. But once you kind of get it in there, then it'll all centralize up and be where it needs to be. The next thing is that this lay shaft needs to be inserted through the side of the box. So there's a hole in the side of the box. It's now running through the center of that gear. I normally just get a little finger in there to line up the shaft and pop this in. Now I know what you're thinking. He's forgot the truss washer this end. I haven't. The good news with an A-series box like this is that truss washer can go in second. So just pop the lay shaft back a little bit. Okay, so the shaft is sitting in there. So that's the second truss washer, and I just slot that down alongside the lay shaft. Okay, it can take a little bit of a wiggle just to get it to go in there. Make sure that that's back all the way. And then we give it a little bit of a wiggle to get that in there. Now, so we're very close there now. If you have trouble, getting that truss washer to line up perfectly, you can get through this side with a flat blade screwdriver or a punch, and you can see I just squared up that truss washer there. Once that's in place, then with a dead blow hammer or something like a copper hammer, either I just like using the back of the handle of a hammer, just straightening up that truss washer again, just trying to get it dead in line. And then your lay shaft inner will pop into place. I want you to note that there's a slot across the back of this lay shaft, this sort of slot here. That's to allow you to put a screwdriver in there to clock the rotation of the lay shaft. I'll show you now why that's important. Okay, I have my dial indicator gauge set up on one of the teeth of the lay shaft, and I'm pressing my screwdriver one direction to slide the lay shaft all the way down the box, and I've set my dial indicator at 0. I'm now going to put my screwdriver the other side of the box and press on the lay shaft in the other direction. I'll set her 0 again. Okay, now we've got the other side of the box without hitting the dial indicator gauge. Trying to set this up in such a way that you guys will see it as well. And we slide our lay shaft. Okay, so we've got, if I press hard, I'll get 0.11 and 0.1. So we've got 0.1, which is sort of 3 thou or circa 3 thousandths, 3.5 thousandths, we'll say. So that's perfect. That's exactly what I want. I said I wanted to sort of shoot for 4 thousandths. Brand new box, brand new truss washers. Give them a little bit of chance to bed in and settle, and we'll creep right up to that 4 thousandths clearance. It's important that we check that lay shaft to make sure that we do have that right end float, because otherwise, if you've got too much, what can happen is the gears will run off center to the gears they're meshing with on the main shaft and the input shaft. If we have not enough clearance, the lay shaft will bind up inside the box and cause us to get a massive increase in friction, which could damage the lay shaft. It certainly would put huge amounts of heat into the lay shaft bearings and could cause failure in that mode. So with that done, the next thing for us to check is to line up the C washer, and then we are going to check the bearing nip. So this washer is what locks the main shaft, the lay shaft inner and reverse inner shaft in place in the box. You obviously don't want them spinning. So how this works is, and if you remember earlier, I showed you that slot on the back of the lay shaft inner, and I said to you that you have to rotate that in order to get this into position. So you've got to clock the two shafts. You'll see there's a slot across this one here, which is also there to allow you to clock reverse gear idle shaft. So you can turn that kind of left or right to get a bit of angle on that. And then you can use your screwdriver at the other end of the box to give this shaft a little bit of a turn until that goes into place. Okay, just want to take this moment to thank all of our subscribers. Thank you very much everyone who subscribes. I see the new subscribers trickling in. You guys are most welcome to the channel. Thank you for the subscription, and I do hope we give you interesting entertainment to watch on the channel. Comment in the comment section below. I always like to see new subscribers and hear from them. To everybody who is watching this video currently, if you wouldn't mind hitting that like button, it really does help us. It helps the channel to grow and helps us to get out there and in front of a bigger audience. To that note, thank you so much to everybody who has bought merchandise in the merchandise store. Oh my God, it has blown my mind. Billy told me about a month and a half, or well, oh, it's probably 4 months ago now, but that we needed to create a merchandise store and have merchandise available for people off the channel to buy. And in really no uncertain terms, I said, who would want to buy bloomin' HRE merchandise? Who the hell am I to be selling merchandise and have my name on t-shirts? Well, I was completely proven wrong. The HRE branded merchandise has sold better than any of the other pieces of merchandise we have. So thank you. You proved Billy right and made me look like a fool. And I'm have to say, it's one of those times when I'm just delighted to be made a fool. So thank you so much to everybody who has bought merchandise. It really is helping the channel. It is allowing me to spend more time making videos and less time doing other work to pay the bills. So thank you very much. It really is appreciated. And I also want to just mention to those that are making donations to the coffee account, thank you so very much. It genuinely is humbling, and I greatly appreciate the money that comes in on it. We are managing to pay back all of our camera equipment and also invest back into the channel and buy new and better equipment. The day out in the racetrack didn't go exactly brilliant, but one thing that was wonderful was we had the kit that we could shoot video for the whole day, and that is thanks to you, to all of you people that have donated to the coffee account and have really put your money where your mouth is. Thank you so very much. The last thing, and I'm aware that I take your time up in the middle of the videos, and I do really appreciate that all of you guys have been watching these little intros, or these little, should I say, inputs. We have a live again this weekend with Cole. This is the very first time that we are going to go live across both our channels. I am so excited for this. So you guys can, my followers that are watching on my channel all the time, you guys can actually go to my live section and you can set yourself a schedule for an upcoming live. We have it in there. You can hit the button, but also I'm going to put a link in the description down here below. It'll be the very first link below all of the other stuff that you can click and set yourself a reminder. It's going to be great fun. We have a really cool topic coming up. It's power related, and I know everybody likes power related mini content. So make sure you guys tune in for that. Come and meet me live where we can sit down and have a chat. We have a Q&A section in the back end of the live, and I'll answer any questions anyone has there. You just have to pop in, put your question in, and we can have the chat. Generally speaking, our live is about 1 hour and 3/4, so pop in at any stage along the way and I'll be delighted to see you. Let's get back to building this gearbox. So with that tab in there, the next thing we need to do is we need to set what is called the bearing pinch. Now there's a couple of different people who have done videos about this, and they have different ways and means and methods. I have probably built nearly 200 or 300 of these now. I've lost count actually. I don't know how many, but I have to be in the high 200 to 300s at this stage of these gearboxes. And the methodology to which I use is what I find the simplest. It may not be the best, but it certainly is the one that has always yielded me results and has worked out. So what I do is I put this bearing retainer in here. I then put in two of the bolts. I put that bolt in that corner there. And I put this bolt into this corner here, and that's the one where that lock tab is, okay? We get that bolt in there. Sometimes that bolt can be a little bit of a faff because that lock tab might not just be sitting where it should be, but if you kind of rumble the bolt around, you'll probably pick the thread up pretty easily and get it where it needs to be. Then what we do is just get in there with the ratchet and give this a couple of turns until the bolt snugs home. Now, you don't want to torque this. You just literally want to bring the bolt snug home. Okay, because we don't actually want to preload the bearing. We just want that bearing housing sitting snug up to the bearing. What are we setting here? There is a main bearing in the center of this housing. It has a steel clip around it. I showed it to you in the last video. That steel clip stops the bearing from shoving all the way through the gearbox. That bearing outer housing is what they call a sliding fit. So if there wasn't anything to catch it, it would spin in the center of the box. And if it did that, it would wear out the bearing housing and the bearing would fall out of the box and the box would have catastrophic failure. So BMC, in their infinite wisdom, designed this setup with what I suppose can be called a bearing retainer, this steel horseshoe here. And its job is to nip the bearing. How much nip should we have on it? Typically speaking, I'm going to go from imperial to metric and metric to imperial. I know that wrecks everybody's head, but the measurements in all the manuals are given in imperial and all my measuring equipment is in metric. So what is required is generally between 2 to 5 thousandths is what they say of nip. What that basically means is that that housing with those bolts nipped up should be 2 to 5 thousandths away from sitting flush with the box. If it's not, then what we have to do is put a shim in there which will take up that space so that we only get 2 to 5 thousandths nip. Any more than that and it could crush the steel washer or the steel snap ring that goes around the bearing, and the end result of that would be bearing failure again. How we measure that is pretty straightforward. We have the horseshoe in place. I have the bolts just barely nipped, and then I'm going to get my feeler blades. Now, I typically expect to see between 10 and 25 thousandths. There we go, about getting mixed up with millimeters and inches. I typically expect to see between 0.1 of a millimeter and 0.2 of a millimeter clearance here. So that's what I get out. I get 0.1, 0.15, 0.2 feeler blades. And we try those to see if we can get those in. I expect to get 0.1 in there easily. So where are we getting it? We're getting it between the housing and that horseshoe. And I can get 0.1 in there easily. So let's go up to the next one, which is 0.15. Again, that's still fitting in there relatively easily. So let's go to the next one, which is 0.2. Okay, now I'm feeling drag. With 0.2 in there, I'm feeling some drag, which tells me that I must be very close to the right size. So let's get 0.25 feeler blade out, see will that fit in, and then we will know where we are. So I have my 0.25 feeler blade now, and sure enough, just about fits in there and won't fit in there. Okay, so I can just get it in there. It's very tight there. So we're going to call that. So that tells us we've got 0.25 of a millimeter of clearance there. Meaning if we want our nip of 2 to 5 thousandths, we are going to need a spacer or a shim to go in there that'll be 0.2 of a millimeter, somewhere around that. So let me just check my shim stock, and I'll come back with a 0.2 and we'll try that in there. Okay, so I was guessing there, 0.2 was wrong. That would only actually give us less than 2 thousandths nip. So what I actually need is a 0.15 shim, 0.15 of a millimeter. So 0.15 of a millimeter will give us, wait, we just see, that'll give us 5 thousandths. Yeah, that'll give us 5 thousandths nip, which is what we want. We want 4, 3.5, 4. Either way, we're going to be playing around with a thousandths, which is fine. There's no problems there whatsoever. So what I have here is a 0.15. That's giving us 0.1 of a millimeter nip, which 0.1 of a millimeter nip is 4 thousandths, so I'm happy with that. This shim goes in here, lads, between the key plate that keeps those two shafts keyed together. It goes between there and the box. I've seen a few gearboxes come to me where that shim has been put on the outside and it messes up the whole thing. So it needs to sit in there between those two. Slides in there. This horseshoe washer can go one of two ways, so it can be flipped back to front. The way I have it here is in the right orientation. You will know straight away if you have it in the wrong orientation, because none of the holes will line up and you won't be able to get your sea washer into place. So then we'll get the sea washer housing in there, and we will put a heavy lock washer on there. So a couple of people have asked me in the past, do I use the lock tabs that would have came with the original gearbox? I don't. What I actually use is my absolute favorite Loctite, which is Loctite Compound 638, which is actually a bearing fit compound, but it will work for locking threads and aluminium as well. And it's the one I like to use in this situation. I've been using it for years. You get used to something and you just keep using it because you have good success with it. If you guys want to use a Loctite type material, then go ahead and do that. That's completely fine by me. This is just the one I use and it works for me. Okay, and that's all it is. People always ask me, what do you use? I'm showing you now. I use 638. It's worked brilliant for me in the past. And it's still working for me, hopefully going forward in the future. So we get those ones in there. I don't use the little lock tabs that would have originally came with the gearbox. I don't like those little metal lock tabs. They've never worked well for me. They've never gave me good results, so I just don't use them. Some people get good results out of them, some people don't. It's up to you what works for you. And for me, the heavy spring washer and that locking solution, and I've never had one of these bolts back out. I am going to tell you one thing though that you have to watch here with these boxes, and that is the length of those bolts. It's very, very critical. The length of the bolts in that housing there is very critical. If you put a bolt in there that's too long, people get mixed up and use one of the bolts from the housing here or one of the bolts from the side housing here. It will go through the center web and it'll foul first gear here on the main shaft, on the output shaft. It'll catch first gear and it'll lock the whole box up on you. And if you don't catch that until the whole gearbox has gone back into the car and it's all fitted, and then all of a sudden you can't get first gear to engage, or the whole box is locked up, and when you put it into gear you hear a horrible grinding noise, then that's going to be not a nice situation. So just make sure you check that you have the right length bolts there for that. It'll save you a whole lot of hurt down the road, and it'll save you from getting to a point where you run into trouble. So the torque on these bolts is, I normally do them at 15 foot-pounds, which I think is, if I'm right, 15 foot-pounds, it's about 23 Newton meters, somewhere around there. Not super tight. These are a coarse thread bolts. They're UNC into aluminium, not a very strong thread, so you can pull them very easily. So I certainly wouldn't go anything more than that. Now that we have that in place, the next thing we are going to do is we're going to put on the primary input bearing. So that sits, the primary input gear. So that's the drop gear. It sits in there. Next thing to go on for that is a locking washer and a nut. The nut needs to be tightened to a certain tightness. I'm going to show you a trick that I use to get that nut up to tightness. So we need to fit this lock tab. The lock tab has two tangs that go into the two holes that are in the gear. I always bend up the corners of the lock tab a little bit. It just makes it much easier. They come completely flat, but if you bend them up a little bit, it gets you started. It's a very tight spot to be trying to get in at with a punch to pick that up. The next thing is the nut. A small little bit of oil I've just put on the thread just to allow that nut work its way on there. These lay shafts, or these input shafts, are made with the box, so they can be a little bit tight. The next thing we have to do is to make sure that our selectors are out of the way, and we have to engage first gear, and we want to engage fourth gear on the main shaft. That's us in there. Just so you'll know what I'm doing there, I've put this selector here forward into first gear, and I've put this selector here backwards into fourth gear, effectively locking the main shaft solid so there's no drive through the box. It means that it's trying to drive 2 different speed gears, which means that that lay shaft now is locked solid. What we need to do now is we need to tighten this to a specific torque. There's 2 ways of doing this. We can use a huge big torque wrench and pull a specific torque on this nut, or the other option I like to do, and I've worked this out in the past, and it was a brilliant mechanic showed me this trick years ago when I was working on heavy plant. And basically what he showed me was that if you have a situation where you need to achieve a huge torque, you can do that one of 2 ways. One way you can do it is to use a huge torque wrench, or the other way you can do it is torque the bolt once and measure the angle which it turned to get to that torque. If you're going to do something over and over and over, it's a good way to get you there. So the way I did this was I started with a torque of 40 Newton meters. I tightened this nut to 40 Newton meters, and then I pulled the correct torque on it, which was 180 something Newton meters. I can't remember exactly what the figure is because I don't use it anymore. But I then pulled that with a torque wrench. I marked the nut where it started, and I marked the nut where it finished when I pulled that torque from the starting torque of 40 Newton meters. What I achieved was just shy of 90 degrees. In other words, it turned the nut just shy of 90 degrees. Now, going forward, the way I can do that is brilliantly simple. I can put a mark on the nut and a mark on the gear. That's my starting point. 90 degrees from that is going to be that 3 o'clock position. Now all I have to do is turn that nut to 3 o'clock, and I know I'll have achieved the same torque. And believe it or believe it not, it's actually one of the more accurate ways of achieving a torque. If you look at all modern Volkswagen, they will tell you to bring the cylinder head nuts up to a specific torque and then turn them a number of degrees in angle. So when you're trying to achieve really high torques, this is a much more accurate way of doing it. It also means that you can use the ye olde nut gun to tighten a nut without having to worry about over tightening it or getting it to too tight a tightness. The reason I'm showing you this is I know a lot of people out there are going to be in a situation where they don't have access to a huge big torque wrench, or they're not going to have access to some way or means of fixing the gearbox so that they can achieve that angle to tighten it. So this system works perfectly fine. You've got your 2 marks, you use your nut gun to bring this around to that mark, and you'll have achieved the torque. If you're worried about not being able to see that or getting it to that, you can also put the Tipex mark on the socket and you'll be able to find it from there. We're just there now. My air is a bit low today, so it's taking a bit more. And we're there. So what that's allowed us to get to, or to achieve, is we've managed now to get that nut up to torque without needing to use something like a 3/4 inch torque wrench, which are a couple of $100 to buy even a half okay one. So that's a technique or a method. The last bolt to go on here is we have to fit the pinion gear. The pinion gear sits here on the main shaft. There's nothing to go behind the pinion gear, it just literally slides on there. These pinion gears tend to be quite tight because they are from KAD, which they make their tolerances really good because it's a racing item. Unfortunately, the people who make the gearbox, that made the gear kits, didn't work to the same tolerance. So they need sometimes a little bit of persuading. So we just tap that on down the shaft. And the next thing to go on there is a locking washer. That locking washer sits onto the grooves in there. Need to get our punch. Tap that on another little bit. I said these pinion gears can be quite tight. So let's just send that one completely home. So this guy sits onto what is sticking out there, which is those kind of little grooves. It sits on there. And I'm going to show you a trick that I've been doing for a while now. So this is the original pinion nut. And what you'll see on the original pinion nut is that it has this conical cone shape here and a bunch of threads in it. What I have done is I've made my own pinion nut, which is made from a better steel. This is EN24B. I have hardened and tempered it, and I have taken that conical shape off when I made the new nut. I then follow that up with a camshaft nut. So that's the nut that holds the sprocket onto the camshaft. What I then do is I put this nut on first, which is the same as you would put a normal input nut on. That goes on. And we do the same as we did the last time. We bring that nut up to a specific torque, which again is 40 Newton meters. And then we turn it through 45 degrees, not 90 this time, 45. My apologies, I misled you. I was going off the top of my head, and while I'm good at speaking off the cuff, I just want to make sure I'm giving out very accurate figures because I know some people are going to follow this. So I said 40 Newton meters, the same as this. It's actually 80 Newton meters plus 45 degrees. I knew there was a difference in there because this is actually at a much higher torque than that nut is. So this one is 80 Newton meters plus 45 degrees, and that brings you up to the same torque as the book spec. Or you can go for the book spec and use a torque wrench. It is completely up to you. I'm just showing you this is the way I do it. You can do it whatever way you want to do it. The last part of this, why did I turn the nut face down like this? I turned it down like this to add to it a locking nut. So what I use is just a little bit of the ARP assembly lube, just a little small amount of that. Put the ARP assembly lube on the nut and the thread. If you don't have ARP assembly lube, you can just use something like molybdenum disulfide grease or something like that. Run that nut up there the same as you would the primary nut. I'm just using a washer because it's tight on the thread, or a socket here because it's just tight on the threads. And then you want to get your torque wrench, which is set to 80 Newton meters again, and you torque this. The reason I use 80 Newton meters here is that is what the camshaft nut torque is. So we know this nut is designed to withstand that torque. We bring it up to that 80 Newton meters, and what we now have is a double lock nut. So we've got the main shaft nut, which is pinching the primary gear at its original torque, and we've backed that up with a second locking nut to secure it onto the main shaft and make sure that that nut doesn't back off. This is really only something for fast road, track day, rally race preparation gearbox work. Some people might want to do it to be, you know, belt and braces, and if you do, then that is a brilliant way to do it. This is not something that you need huge amounts of tooling and equipment to do. You need a lathe or access to a lathe or somebody with a lathe that can produce a nut for you, Or you could potentially, I've never done it, but I imagine you could potentially turn back that face of the original nut and turn this face of the original nut to allow this go on. I've never done it. I've always made my own in the case of this EN24B tool steel. I've always made them myself out of that, hardened and tempered them according to Machiner's Handbook notes. But you could potentially use something like the original nut if you had access to a lathe and turn it back, and then a camshaft nut to go on afterwards and lock it tight. I've been using this system for a number of years. It came from another guy here in Ireland who I seen using it as well. He's a famous enough mini engineer. Lloyd Hutchins has built some pretty cool minis over the years, and a gearbox that he built for me years and years and years ago had a system similar to this, not this system, but a similar system to this. I recreated my own version of it and I've put it in, and I found this has worked really well for me. I've never ever had a pinion nut back off in any box that I've ever built, and I know a lot of people have suffered from that over the years themselves, so it's something I did. Last thing will be to be done there is to bang over those lock tabs. That is going to bring us to the conclusion of this video. It's already been incredibly long, but sure, I gave you a bit of bonus extra material since I missed a Wednesday and a Sunday video. Well, that's what I'm telling myself anyway. The next and last part to this video will be doing the machine work on the diff and fitting the diff to this housing. There's not a lot of machine work to do to the diff. I just want to show you how you set one of those old Salisbury diffs and measure it to see what torque it's putting out, what clearance it is. That'll be the last part. Thank you very much for following me along this episode, and I'll see you on the next one. F*** off, Billy.